In our previous foundational video on RAG, we broke down the theory of retrieval augmented generation, why LLMs hallucinate, and how semantic search provides the ground truth they need. We used the hypothetical example of an employee trying to expense a $1,200 monitor to show how RAG enforces company policy. Today, we're stopping the talk and starting the build. Welcome to CareerLink. In today's video, we'll be going from a blank folder to a fully functional Dockerized RAG application using the Antigravity IDE in an hour. Also, we have deployed the RAG application tool that we will try to build today on our video. So we have deployed it to the CareerLink platform. So make sure to try that out before we begin this video. So let's begin. First step, opening up a clean workspace. We'll create a new folder on the desktop and call it RAG. Now that we are in, you'll see the agent panel on the right. This is where the magic happens. I'm switching the conversation mode to planning and selecting Gemini 3 Pro to make sure we have the heavy lifting power for the infra setup. I'm dropping in the first big prompt. We need a clean Dockerized setup, a Python FastAPI backend, a Postgres database with vector support, likely using pgvector, and proper handling for environment variables and OpenAI keys. The agent is now generating. You can see it through the architecture. It's breaking down the request into logical tasks, implementation plan, Docker configuration, and the base backend structure. As you can see, it just spit out the implementation plan. It proposes a Docker Compose file for orchestration, a Pydantic-based configuration setup, and SQL Alchemy connection. Looks solid, let it cook. What's the file explorer on the left? The agent is actually writing the code now. There goes the Docker Compose file, the .env template, and the backend Docker file. It's moving into the source code, setting up database.py for the connection logic, main.py for FastAPI entry point, and config.py for our settings management. It's basically building the skeleton of our entire app in just few seconds. Now it's generating a walkthrough markdown file that you can see on the screen. And this markdown file, it's great for documentation. It's explaining what exactly is included. From the basic Postgres checks to the FastAPI events that are done here. So this is a really important and necessary step in our configuration. And through this markdown file, we can also review the steps and necessary implementation plan as well. Also, now let's take a second to review the Docker Compose file. There are two services, a Postgres database with the pgvector enabled and a backend API service. The database is configured with environment variables, persistent storage, health checks, and runs on port 5432. The backend connects to database using an Postgres URL, and it passes environment variables and exposes an API on port 8000. And the Docker file builds a lightweight Python 3.1 3.11 backend image, installs required system and Python dependencies, runs the FastAPI app using UVCon. Now it's time to get our hands dirty in the terminal. We are running Docker Compose build. We have got to give the system command to download the pgvector image and build our backend image. So while it's trying to do that, we will wait for the layers to download. As you can see on the screen, it's trying to download. It's pulling the Python 3.11 Slim image and installing our system dependencies, stuff like libpqdev for Postgres and GCC for compiling some of our Python packages. You can see on the terminal as well. Now, once that step is completed, meaning the build is finished, we will bring it to life with the Docker Compose. The logs are streaming in, Postgres is initializing the database system, and our backend is now live and listening on port 8000. Backend is up, but it's empty. We need a way to get data into our system. I'm prompting the agent to add a data ingestion pipeline using LangChain. We want to be able to upload PDFs or text files, extract the content, and index it. The agent is planning again. It's going to add a new router for ingestion, a service layer to handle the logic, and update our requirements to include services like LangChain, PyPDF. You can view on the screen. And there it goes, writing the code. It's adding ingestion.py to our routers. It's even including logic to chunk the text, crucial for RAG, so we do not overwhelm the large language model with context. Now, after we have added the new dependencies, we need another Docker Compose build. Because we have added new dependencies, as I said, you can see it installing the new libraries here. So I just write the Docker Compose up and it's going to run our database and backend with new packages. So we just basically use Docker Compose, build, and Docker Compose up here. A little bit of debugging. We're seeing some connection issues in the logs as well. The backend is trying to find the database before it's fully ready. The agent is already on it, adjusting the service names and as well as the wait for it logic. So we can see that clearly in the terminal. Now, agent applied the fixes to database.py. We can see that with the red indication over here. Let's restart. So perfect. Let's review the logs. The logs show that the connection is successful. So we are officially connected to the vector store. Let's check the browser. Okay, so it returns our RAG backend is running message. Now The real test is Swagger UI @/docs. There's our post ingestion upload endpoint. So I'm going into the .env file to add my OpenAI key so we can generate embeddings. Back to Swagger, let's try a test upload. I'm picking a markdown file, execute, and probably we'll get a success with it. So yeah, 200 success. The file was processed and chunked. So this is a good milestone. Now opening the Git panel, let's stage these files. So we add a commit message, initial setup of RAG system, and then we will push it. So always commit when it's walking. Next phase, the retrieval and generation flow. I'm asking the agent to implement the core logic where the user sends a query. The system finds the relevant chunks in Postgres and sends them to the large language model to get an answer. So the agent here is building out the RAG service.py. This is the brain of the app basically. So it's using cosine similarity that we discussed in our previous videos as well. In the SQL query to find the best matches, it's also setting up the prompt template to ensure the AI only answers based on our documents. Quick review of the new RAG router that we're gonna do here soon will reveal everything. So let's try to review the new RAG router over here. So everything looks tight, and so let's do another commit to maybe save the core flow logic. Now time for a phase. We can just live in Swagger forever. I'm telling the agent to build a React Vite based frontend. So we basically need a file upload area and a clean chat interface where we can type in. So the agent is planning a node based container for the front end. It's going to use the most popular tech stack, maybe Tailwind CSS for the styling and Lucid for the icons. So it's trying to create a really minimal and well adapted type of front end, and it will try to dive deep into our folders configuration and do that. So it's scaffolding out the source folder now. In the terminal, you can see it running npm create Vite. It's installing Axios for API calls and setting up the proxy so that it can talk to our Python backend. And one last Docker build to include the front-end container. We're building the whole stack now, from front-end to back-end, as well as the database. And the agent is trying to achieve that goal. And once it does that, we will be live on the local host 5173. Look at that, careerlink.ai, a professional looking dashboard, that is ready for data. Now let's load it up. I'm uploading 3 documents: an expense policy, a finance memo, and an HR addendum. You can basically see the indexing status for each on the left side. Once they turn green, then we can confirm that the knowledge base is ready, basically. Now here's the $1,000,000 question that we have been asking since our previous videos, on the foundational video as well. So I work remotely. Can I expense a $1,200 monitor? And we just type it, and we're waiting for the retrieval, right? So let's just type the full sentence first. There it goes. And we just send it, and we're waiting for the retrieval, right? Okay. And there's the answer. It says no because there's a limit of $800. It even cites the company expense policy.pdf and the HR addendum as sources. And that's what we exactly need, right? So to finish things up, I am asking the agent one last time to polish the user interface, adding conversation history and making the chat a bit more fluid. You can see the agent updating the React components in real time. Okay, so testing one more time, right? We type in what's the reason for the pause, right? First we send the initial query, and then it provides us the answer, and then again we type in the question that we wanted to ask, what's the reason for the pause. And once we type in, the system will probably pull the finance memo about Q1 2026 budget constraints, and it will provide us the answer. So we just build a full stack RAG system in an hour. So not bad at all. And that's how you build efficient RAG systems using Google Antigravity. And for more such videos, please subscribe to our YouTube channel, and we'll keep you updated with new contents. Also, as we said in our previous video, we have an upcoming circle in our platform, careerlink.ai, on RAG mechanism. So if you are interested in joining that, please go to our platform and join it. Also, for other updates on AI tools, resources, circles, and many more, just visit our website careerlink.ai. And also make sure to try out the tool in our CareerLink tools section that we have provided in the description. And that's it for today. Thank you.